Now we're talking about dividing positive and negative fractions. So let's back up a little bit. With addition, we work with opposites. When we add opposites, what do they equal? They equal 0, right? Well, when we're dealing with multiplication, we work with reciprocals. When we multiply reciprocals, what do they equal? They equal 1. So for example, 3 times 1/3 is the same thing as 3 over 1 times 1 over 3. 3 times 1 is 3. 1 times 3 is 3. 3 over 3 equals 1. So 3 and 1/3 are reciprocals because they multiply to equal 1. So let's figure out the reciprocal of some numbers. If I have the number -2, I want to figure out what I'd multiply by -2 to equal 1, and that would be the reciprocal of -2. Well, -2 is the same as -2 over 1. So what would I multiply by to get positive 1? Well, first of all, what do we know about the signs in order to get a positive 1 as our answer? When you multiply one negative, what do you have to multiply by to get a positive answer? Another negative, right? And so what's the reciprocal of -2? It's -1/2, because that would equal 2 over 2, which is 1. So 2/3 times what would equal 1? What do you think? The reciprocal, you can think of it as taking the fraction and flipping it upside down. Will look just like the original fraction but upside down. And when we multiply, we end up with 6 over 6, which equals 1. So reciprocals always have the same sign, therefore they multiply to give you a positive, and they're always the upside down version of each other. So -4/5 times what is going to equal 1? If you said -5/4, you're correct, because it's -4/5 flipped upside down, same sign, gives you a positive. Again, 4 times 5 is 20. 5 times 4 is 20. That's why we end up with 1. What about -6/5? What would you multiply that by to get 1? If you think it's -5/6, you are correct. With addition, we always rewrite subtraction and change it to addition using our opposite property. So we use keep, change, opposite. -2 minus 7 is going to become -2 plus -7. We can do the same thing with division. We can rewrite all division as multiplication, but instead of using opposites, we're going to use reciprocals. So -5/8 divided by -3/4. We're going to use keep, change, reciprocal. So same idea as what we worked on with integers. With integers, it was keep, change, opposite, meaning that we would keep the first number, -2, and then change the minus to a plus and the +7 to a -7. Well, same idea here. We're going to keep the first number. So in this case, -5/8 is my first number. We're going to change division into multiplication. And then we're going to write the reciprocal of the last fraction. So that would be -4/3. So keep, change, reciprocal, keep the first fraction, change division and multiplication, and reciprocate the last fraction. It's always the fraction after the division symbol that gets flipped upside down. Just like it's always the number after the subtraction symbol that gets changed to the opposite sign. Same idea for both. So now let's talk about dividing fractions. So with dividing fractions, you always want to change all mixed numbers to improper fractions, just like we did with multiplication, because ultimately that's what we're going to be doing, is multiplying. Then you also want to change the division sign to multiplication and flip the second or last fraction, the fraction that's following the division symbol. is the one that will flip upside down or write the reciprocal of. So now at this point you have a multiplication problem. So you continue with multiplication steps. Cross cancel, multiply numerator times numerator, denominator times denominator, simplify your fraction, and change back to a mixed number if necessary. So let's do some examples using all these steps. Now we have negative 1 and 2/8 divided by 1 and 1/4. So the very first thing we're told to do is to change all mixed numbers to improper fractions. So let's do that. So 8 times 1 is 8 plus 2 is 10, so that's negative 10/8 divided by 4 times 1 is 4 plus 1 is 5 divided by 5/4. So the next thing we're going to do, so we did our first step, is to change the division sign to multiplication and flip the sign following the division. So now I'm going to keep, change, reciprocal. So I did the second step, which turns this problem into a multiplication problem. Now, do not try to change your division into multiplication at this first step. You need to make changing your mixed number into improper fractions your very first step. Do not try to combine that with keep, change, reciprocal. That's one of the main ways kids make careless mistakes. So now that we have multiplication, what do you always do for your multiplication problems to start off with? You cross cancel, right? So 4 will go into 8 twice, and 5 will go into 10 two times. Now there's one other place we can simplify. Do you see it? You can always simplify on top of one another, right? 2 goes into 2 once. This problem is really easy once we do all of our canceling. We end up with a negative times a positive, which is negative. 1 times 1 gives me 1 in the numerator. 1 times 1 gives me 1 in the denominator. So my answer is negative 1. Try the problems on the next page. Keep in mind as you're working on them that this is the division bar for the second problem. So it's 4/7 divided by 3/2. For the first problem, you should end up with 5 times 5, because the reciprocal of 1/5 is 5, which is 25. In the next problem, we have 4/7 divided by 3/2, which becomes 4/7 times 2/3. There's nowhere to cross cancel, so you end up with 8 over 21. The next example I'd like to talk about the keeping up with your negatives. The whole value 21/4 is negative. The whole value 8/7 is negative. So you're multiplying two negatives to get a positive. So you don't have to keep up with those negatives as you're cross canceling. So you end up with negative 21 over 4 times negative 8/7 when you multiply by the reciprocal, and then you're just going to multiply straight across once you cross cancel, and we get 3 times 2, which is 6. 1 times 1 is 1, and a negative times a negative is a positive, so you end up with 6. I'd like you to try this problem using the order of operations. The answer to this problem is 1/3. So here are my steps in case you did not get 1/3. Take a minute and look through my steps. On the next page, you'll see division happening 3 times. So the way you deal with this when you keep, change, reciprocal is the same way that you would deal with adding the opposite. If we had 4 minus 2 minus 6, we would always change subtraction to addition and then assign the opposite sign to any number following subtraction. So since the 2 is after subtraction, we're going to give it the opposite sign. Since the 6 is after subtraction, we're going to give it the opposite sign. Same idea here, only we're dealing with multiplying by reciprocals. So I'm going to rewrite this as negative 25/36 times negative 12/15 times 3/4. So every fraction that follows a division symbol, we're going to reciprocate, and we're going to use all multiplication. One thing I want to mention about the negatives is when you have a negative fraction, if I have negative 1/2, that could be written as 1 over negative 2, or it could be written as 1/2 with a negative beside it. All of those mean negative fraction, or a negative value. If I had negative 1 over negative 2, that's actually a positive value. It's the same thing as 1/2. So let's talk about this for a minute because it's very important to understand. So if I have a negative in the numerator and a positive in the denominator, this is ultimately a division problem with unlike signs. And we know that if you have division and you have different signs, the answer is always what sign? Negative. So that's why the entire value is negative. Same thing with 1 over -2. That's really 1 divided by -2, which gives you a negative value since they're different signs. And of course, negative outside of the entire thing is like having parentheses, letting you know the opposite of 1/2, which is -1/2. And again, if we have a negative in the top and bottom, that's like dividing with like signs, with the same signs. And when you have the same signs and you divide, what is the sign of your answer? It's always positive, right? So -1 over -2 is the same thing as -1 divided by -2. And that's going to give you 0.5, just like 1 divided by 2 would give you 0.5. Same signs give you a positive with division. Different signs give you a negative with division. So that's just a side note. I'd like you to go ahead and complete this problem and see how you do. So after some cross canceling, I ended up with 5/12. I know my answer is positive because I have an even number of negatives and I'm multiplying. So when you have an even number of negatives when you multiply or divide, you'll always end up with a positive. I'd like you to try this next problem. You should end up with -1.5. Make sure to show all your steps. Next, we're going to talk about dividing fractions that have negatives and variables in them. So this is a lot like the multiplication with fractions that had variables in them, because all we do is change it to multiplication. So I'm going to keep the -6, but I'm going to write it as a fraction, change division to multiplication, and reciprocate the fraction that follows my division symbol. So keep, change, reciprocal. Now that I have a multiplication problem, I can complete it like I did before by cross-canceling and anywhere that that's possible. And then I multiply numerator times numerator. -3 times 3 is -9y. And 1 times 1 is 1, so that equals -9y. Try this next problem and see how you do. I ended up with positive 1 and 1/5. We do have two negatives here, so therefore our answer is positive. Notice that I had accidentally dropped a negative, but I looked back at the original problem to double check. Negative divided by negative should give me a positive. On the next page, try the next problem. You should end up with -2x over 3. Go ahead and try this last problem. I ended up with 28. Feel free to check my steps. Make sure that you're cross-canceling. That is essential with these problems.